f of x1, x2 equals square root of x1 plus 3 square root of x2 square. The price of both inputs is 1. So price of input 1 and price of input 2, they're equal to 1. Find the marginal rate of technical substitution, find the optimal cost function, meaning the cost minimizing input levels, x1 and x2. And then, in addition to the variable cost you found in part B, suppose also that the firm's fixed cost is 9. All right. If all firms in this competitive market has the same technology, what would be the long run market price? Okay, so that part of the question is actually required to know something about a market, and so we should ignore this. I'm sorry, I should have erased this part. It's there by mistake. So I'm going to ignore part C. What we can do is, so in part A, marginal rate of technical substitution, what is it? So these are sort of standard questions. And part B, optimal cost function, what is it? And in part C, what is the optimal quantity? I mean, how much quantity is this firm going to produce? Well, here, obviously, I need to use this market price. So it's not given in this question, right? So the optimal quantity Q, assuming that market price is sum P. Remember, this firm is a competitive firm. So what does that mean? We know, at least we assume we know, that if the firm is a competitive firm, which means the firm is operating in a competitive, perfectly competitive market, and so the firm is going to take the price as given. All right? So given that the market price is P, what should be the optimal quantity? All right? Okay, so let's solve it. So what is the marginal rate of technical substitution? Well, remember, the marginal rate of technical substitution is very much like marginal rate of substitution in the utility maximization problem. Is basically the slope of the isocost curve. So, isoquant curve. So the isoquant is basically a level curve where we set the production function to a constant. So f of x1, x2 equals to some constant, and draw all the x1s and x2s, which are going to give me the k level of output. All right, this is how we basically draw an isoquant. And obviously, if you change k, if you increase k, because f is an increasing function of inputs, x1 and x2, so higher k means you will have a higher level curve, and lower k means you will have a lower isoquant curve. So the marginal rate of technical substitution is the slope of this curve at any point. All right, so for example, at this point, this is how we find the slope at that point. We basically draw a tangential line and calculate the slope of this tangential line. So equivalently, it's nothing but minus marginal productivity of input 1 divided by marginal productivity of input 2. So what is marginal productivity of input 1? It's basically the partial derivative of the production function with respect to the first input. And don't forget those minus signs. And because we do have this minus sign because those are decreasing curves, all right? And so we do have a minus sign here. All the slopes are going to be negative. All right, so what is the marginal productivity of good 1? Again, this is an ugly looking production function, but as far as I remember, the final solutions are going to be sort of easy, easy functional forms. Let's see. So 2 times square root of x1 plus 3 square root of x2 to the power 2 minus 1, so 1, times the derivative of inside, which is basically there's no minus there. I have 1/2 x1 to the minus 1/2. That's it, because the derivative of 3 square root of x2 is 0. All right, so what else? Well, what is the marginal productivity of input 2? Well, it's 2 parentheses x1 plus 3x2, and again, the derivative of inside, this time with respect to x2, so it's going to be 3 divided by 2, x2 to the power minus 1/2. All right, nice thing, this 2 and 2 will cancel out, this guy and this guy will cancel out. All right, so obviously here I can cancel these two terms under the assumption that x1, the optimal x1 and the optimal x2 are not going to be 0. If they both 0, so this is 0 divided by 0. So you can't really cancel zeros. Be careful. But the thing is, I mean, how can I be sure about that x1 and x2 will not be 0? Well, because if you drove the isoquant of this production function, you'll see it has this nice shape, meaning the optimal point is going to be on the interior. There's going to be no 0x1 or 0x2. So for that reason, I can fairly assume that none of them, I mean x1 and x2 are not 0, and hence I can cancel these out. Obviously they can't be negative, you know, using negative input means nothing. So what else? I have 1/2 and this 1/2 cancels out. So remember, this is basically 1 divided by 2 squared of x1, and this guy 3 divided by x2 square root. And so I basically flip this, and so what I'm going to have is the following: square root of x2 divided by this 3 and 2 will be multiplied 6 square root of x1. All right, so this is, oops, I forgot my minus sign. Don't do that. So this is going to be equal, so this is going to be my marginal rate of technical substitution. Clearly it depends on x1 and x2 values. Makes sense. So that's part A. Well, now part B. Well, what is the optimal cost? Well, first of all, what is the optimization problem we solve? Well, the optimization problem is the following: minimize the cost, right? So what is the cost here? It's like the minimizing or finding the expenditure function, or sort of the Hicksian demand, remember, in the utility theory. So we minimize the cost. So what is cost? Well, here the only cost that we care about is the input costs. So price of input 1 times how much input 1 you will use, plus price of input 2 times how much input 2 you're going to use. Well, P1 and P2 are given to be 1, right? So therefore, can I write this as x1 plus x2? Yes, sure, of course you can do that. All right, so let's leave this minimize x1 plus x2. All right, so I would like to minimize this by choosing what? By choosing x1 and x2, some non-negative reals, subject to, obviously, I would like to produce some quantity level k, but we usually denote the quantity q, and this technology is my constraint, right? I mean, I cannot produce as much as I want because I have a limited technology, and this limited technology is given by this constraint. F of x1, x2 is equal to q. I would like to produce q units of output. So this is the optimization problem I need to solve. How can I do that? You can write down the Lagrangian, solve the first order conditions, or alternatively, because it's going to be equivalent, at least for this question, you can solve marginal rate of technical substitution equals to price ratio, minus price ratio, right? If you solve the Lagrangian of this problem, you're going to end up this equality anyway. So you can save some time by skipping the Lagrangian and basically starts from this point. So what is the MRTS? We already found it. It is minus square root of x2 divided by 6 square root of x1 equals, what is the price ratio? It's 1 over 1. But don't forget the minus. So those minuses will cancel out, all right? So if you forget minus somewhere, these minuses will not cancel out. So you're going to have square root of something divided by square root of something else equals to minus term, which is impossible, right? Because, you know, x1 and x2 are positive numbers, so their squares cannot be negative. So that means you forgot minus sign somewhere. All right, so be careful about that. So how can I solve this? Well, simple, right? Square root of x2 equals 6 square root of x1. If I take the square of both sides, I'm going to get rid of the square root, so it's going to be 36x1. So that means if you would like to minimize your cost, you have to use the input combination that satisfies this equality. You have to use 36 times more good 2 than good 1. So if you're using 1 unit of good 1, you should be using 36 units of good 2. If you're using 10 units of good 1, you should be using 360 units of good 2. That combination is going to minimize your cost. The question is, how much x1 should I buy? 1, 10, 100? Well, that depends on how much quantity you would like to get. But the problem is I don't know how much quantity I would like to produce. I'm going to answer this in the last part. Well, fine. Let's suppose I would like to produce Q units of output. So that means I'm going to find the input combinations, the input levels as a function of Q. Fine. So you tell me how much quantity you want to produce. I'm going to tell you how much input you need as a function of Q. All right. So that means I have to relate this Q with my input combination x1 and x2. How can I do that? Well, use the constraint that I have. So my constraint basically says the following: square root of x1 plus 3 square root of x2 square is equal to Q. Okay, so I also know that x2 is going to be equal to 36x1. Okay, solve for them. Solve x1 and x2. I can do that because I have two equations, two unknowns, x1 and x2. Remember, Q is not an unknown here. Q is a fixed parameter. So how do I solve it? Well, simple. Whenever you see x2, just plug this guy, 36x1. So when I do that, when I plug this here, I'm going to have square root of x1 plus 3 times square root of x2, but it's going to be, so 36 is going to leave that square root as 6, so it's going to be 16 square root of x1 squared equals Q. Well, do not take the square of this. Instead, rather, take the square root of both sides. So this is what you're going to get. So what do I have here? I have 18 square root of x1 plus 1, so I have 19 square root of x1, which is equal to square root of Q. What does that tell you? Well, that tells me that x1 is equal to Q divided by, right? I'm taking the square of both sides, 19 to the power 2. I don't know what that equals to, 280 something, I guess. But you know what? Who cares? Leave it as it is, 19 square. Right? You don't have to use calculator all the time. So this is how much input 1 I'm going to use. Again, this is not 9. Sorry, sometimes my 9s and Qs are the same. So this is Q, the quantity. And then x2, well, x2 is 36 times more than this. So that means x2 is equal to 36 Q1 divided by 19 square. Again, you don't really have to simplify it, just leave it as is. If you have a calculator, fine, calculate them, but otherwise you can leave them as is. Okay, so this is how much x1 and x2 input I need to use if I want to produce Q amount of output. That's the least costly input level. If you use less input than these, less than this input and less than this input, well, you're not going to be able to produce Q units of output, first of all. And second, if you want to, if you use more input than those levels, well, you will be able to use Q units of output, but this time it's going to be more costly. Remember, I am trying to find the least costly input levels to produce exactly Q units of output. And it's those x1 and x2. Well, did I answer this question? What is the optimal cost? No, not yet. There's just one more step I need to do. It's like, remember, my cost is x1 plus x2 because the prices are equal to 1. So the optimal cost, all right, which is a function of quantity, is nothing but x1 plus x2. But what are those x1 and x2? They are these guys, all right? So x1 is equal to, remember, Q divided by 19 square plus 36Q divided by By the way, why I have Q1 here, I have no idea, I'm sorry. 36Q divided by 19 square. And so basically, my conclusion is that 37Q divided by 19. So 37Q divided by 19 square. Okay. 37 and 19, they don't cancel out. 38 would be, but well, whatever. So that's the optimal cost function. The marginal cost is fixed. This guy, 37 divided by 19 square. So now, let's talk about optimal quantity. So here, well, now I understand why this question wasn't asking optimal quantity, because you'll see why. So, optimal quantity, well, how do we solve this question? Well, optimal quantity to what? To maximize profit. So this time, the optimization problem is the following. Maximize profit by choosing quantity, which is some non-negative real number. Do I have any subject to? Not really, because my technology is no longer an objective, a constraint. Why not? Well, because I already incorporated this constraint into my profit function. What is my profit function? My profit function is the following. Revenue minus cost. What is revenue? Price times quantity. All right, minus cost. What is my cost? It's 37Q divided by 19 square. So this cost already incorporates my production function. So therefore, your optimization problem is just maximize pi by choosing Q. That's it, no constraint. What if you said something like this? Maximize pi, which is exactly this guy, subject to, I don't know, f of x1, x2 equals of Q, something like this, right? Meaning you put the constraint there, although it is actually not a constraint. Can I do that? No, you can't do that. I mean, you'll see this optimization problem is going to give you exactly the same solution. Right? It should be giving you the same solution. Alternatively, you can you can solve this quantity by solving the following alternative optimization problem. Maximize profit, but the profit is what? Profit is equal to P times Q, right? The revenue, minus cost, which is P1 x1 minus P2 x2, all right? Subject to, okay, let me leave this subject to. So here my profit is, P times Q, the revenue, minus cost. Remember, cost is here. The only cost I have is the variable cost. I assume that there's no fixed cost. All right. For all our questions, assume that there's no fixed cost unless the question gives you that. And by the way, maybe just a minute pause. Even if we knew that this firm has a fixed cost, it actually wouldn't change anything because the fixed cost does not alter the marginal conditions. All right? The marginal conditions only influence the variable cost, meaning the MRTS equals to price ratio, and then what we did in part A and B would still be the true sort of solution if we had a fixed cost for this firm. All right? So let's come back. No fixed cost for simplicity. I am maximizing this fellow. It's different than this pi because I did not put the cost for optimal cost function. I instead put the, how should I call this? This is the raw cost function. This is the optimal one. All right. So the raw cost function is the one that is not optimized yet. So when I solve this optimization problem, what is my choice variable? First, P is fixed number, right? Because this firm is a competitive firm, takes the price as given. But Q is a choice variable, so that this firm is going to choose quantity. Is that it? Well, no. This is not an optimal yet cost function. So you should also optimize that one. So within an optimization, you're sort of another thing that you should worry about, optimizing the cost. So you should also choose x1 and x2 wisely if you want to maximize this entire thing. So all of them are some non-negative real numbers. So once I have x1 and x2 now choice variable, I need to worry about whether I should put the constraint or not. Do I have a constraint about x1 and x2 and q? Are they independent? No, they're not independent. x1, x2, and q, they're very much dependent according to my technology. So subject to now kicks in according to this production function. So f of x1, x2 must be equal to q because I don't want to choose more than q. I mean, I don't want to choose x1 and x2, which is going to be too much that I produce more than q, right? I want to choose q. So therefore, I have to choose x1 and x2. That's going to give me exactly q units of output. All right, so you either solve this or solve this. Doesn't matter. You must end up the same q, same x1 and x2. All right? But obviously, in this question, I'm going to do this maximization problem because I already sort of found what the optimal cost should be. All right? So I don't really need to solve this again by choosing x1 and x2. I already did it in my part B. All right, so how do I maximize this? Very simple. First order conditions. Del pi, del q, set it equal to 0. What do I get? I have p minus 37 divided by 19 square equals 0. So p equals 37 divided by 19 square. Very common mistake. What the heck does that mean? Q is vanished. Remember, I want to find Q. Well, don't be too robot when you solve a problem like this. So look at this profit function. This is a linear function, linear on Q. So obviously, is linear function has a fixed slope. And so you found its slope to be this. It may be equal to 0. It may be positive, meaning greater than 0, or it may be less than 0. All right? So that means the optimal solution doesn't have to satisfy the first order conditions. The optimal solution may be on the boundaries. What the heck does that mean? That means the following. Suppose P is greater than, well, let's start with less than. P is less than 37 divided by 19 square. What does that mean? That means the following. This derivative is negative, right? So if derivative is negative means what? This profit function, remember this is a linear function, its derivative is negative, which means it has a negative slope, which means this straight line is actually a decreasing line. So this is Q, this is profit, all right? I mean, this starting point doesn't necessarily have to be, this. Maybe it started from 0. I don't know. Okay, so what does that mean? That means the optimal quantity, therefore, is to choose Q equals 0 because it's a decreasing function and it takes its maximum value from when, Q is the minimum because it's decreasing with Q. And so if you want to maximize it, you have to choose the smallest Q, which is 0, meaning not producing anything. Suppose P is greater than 37 divided by 19 square. What is this then? Well, the thing is, the market price is strictly higher than, your marginal cost. So price greater than marginal cost means, boy, keep producing, never stop. So what the heck does that mean? Does that mean Q is equal to infinity? Well, don't forget, infinity is never a number, right? You can't really pick infinity. But that basically means unless this problem imposes any sort of constraint for where the Q is coming from, I mean, maybe the firm is constrained to choose Q in between 0 to 100 for some reason, right? The 100 is the maximum capacity of this factory. You can't produce more than 100 maybe. So therefore, Q has to be 100. But otherwise, there's no solution. I mean, if there's no Q can be any number greater than or equal to 0, well, then there's no solution. Because there's no maximum, right? And when p is equal to 37 divided by 19 squared, well, you know what? Everything is solution, meaning q equals 0 is a solution. I don't know, q equals 1 is a solution, 2 is a solution. Everything is a solution, basically. So let's make sure what the marginal rate of technical substitution is. Is it really this divided by 3 or not? So that means it's 2 square root of x1 plus 3 square root of x2 inside 1/2 x1 minus 1/2 divided by 2 3 1/2 x2 minus 1/2. Yeah, where the hell did I get this 6? Oh boy. Yes, these guys cancel each out. This 1/2 1/2 cancels out. So I have 3 only. I don't know where I got the 6. So that's so I send the x2 guy to here and x1 guy to here, and so it's exactly, yeah. So don't forget the minus. So MRTS is this divided by 3x1 squared, not 6. And so the rest of the question, the solution should be corrected accordingly. But again, the approach is going to be exactly the same.